Okay, today we're going to find probability. Quick reminder, probability is the likelihood of an event, so you can write it in three different ways: a fraction, a decimal, and a percent. Make sure your decimal is between 0 and 1, and your percent is between 0 and 100. Theoretical probability is the type of probability we look at the most. It just means that every single outcome is equally likely. And then this is our notation. So the P stands for probability of a particular event. You would do your number of favorable outcomes, or what you're looking for, over your total number of outcomes. Theoretical probability of things we deal with a lot in math are like flipping a coin or rolling a dice. So those are examples of that. Here we're going to look at an example as if we were randomly generating some numbers 1 to 100. Inclusive just means that we use both 1 and 100. We're wondering, what's the probability that our number is a multiple of 20? Well, if we find our total number of integers that are generated, we have 100 numbers. So that would be our denominator, and then multiples of 20, 20, 40, 60, 80, and 100 gives us 5 over 100. Simplifies here. Okay, next I want to find the probability of our shaded region in this picture. So we have a square and a circle. I gave you the area formulas because you'll need both of those. To find the probability of our shaded region, you have to find the area of your total and then find the area of this shaded region as well. I gave you that fraction. You guys just need to do the work. So please finish this problem. Okay, we're going to look at probabilities with permutations and combinations. So if we're in a parking lot and every parking space has a number, a two-digit number, and no two parking spaces have the same 2 digits, we need to find the probability that a spot chosen has 2 even numbers. So the first thing we need to think about is, does the order of our numbers matter? And they do, because 14 is very different than 41. Therefore, we have a permutation. So we have 10 digits, 0 through 9, that we can choose from. And for each spot, we choose 2 of them. So P, permutation of 10 items chosen 2 at a time, comes out to be 90. Then we need to figure out, what about our number itself? If we want both even numbers, then we know that we have 5 even numbers if we use 0. And we're choosing 2 of them. So permutation of 5 objects chosen 2 at a time gives us 20. So the probability of landing in one of these spots, given that many total, is 20 over 90, which simplifies to 2/9, or roughly 22%. Here is another example that's similar. If we have 22 books in a crate and I ask a student to choose 5 books, we want to know, what's the probability that the student chooses the first 5 volumes or the last 5 volumes? Okay, the order that we pull these numbers or these books does not matter. We could pull the first volume and then the 4th volume and then the 2nd volume and so forth. So the order doesn't matter, which means it's a combination. So we have our total ways to pick the book would be our 22 books chosen 5 at a time. That gives us that 26,334. Now, whether we pick the first 5 volumes or the last 5 volumes, that's just 2 options. So we have 2 and we want one of those options. So 2 choose 1 is 2. Our probability then is 2 over 26,334. Simplifies to 1 over 13,167. That's about 0.008%. So a very, very slim chance of that occurring. Independent and dependent events, we just defined what they were the other day. Independent, remember, they don't affect one another, so we take the probability of the 2 individual and multiply them. That is a multiplication dot in between. Dependent, we still multiply, but here we have probability of A times the probability of, we read this, probability of B given A. That just means we find our probability of B, but we assume that A has already happened or occurred. So let's look here. We have to decide whether this is independent or dependent and then actually solve. So we have random numbers generated, 1 to 100 again. And we want to know, what's the probability that I pick a multiple of 20, and then I also pick a number greater than 90. These are 2 separate numbers, so we would have 2 numbers being generated. Well, what we generate here does not affect what we generate here because they are random. So multiple of 20 we talked about was 5 over 100. A number greater than 90 would be 10. There's 10 numbers, 90 through 100. Simplify both of those. We get 1 over 20 times 1 over 10 to get 1 over 200 as our probability. So 0.5% chance. Okay, here we have a bag that has 2 red marbles and 6 blue marbles, and we want to know what's the probability of picking a red marble, keeping it out, and then picking a blue marble. So find that probability, please. Last thing I want to talk about is odds. So when we hear the word odds, it's just the likelihood of an event occurring. Odds in favor means that we're going to list our favorable outcomes and then compare it to our unfavorable. Odds against means we list our unfavorable and then our favorable. So an example, if we use our marbles from the last example, we have 2 red marbles, 6 blue. What are the odds in favor of red? We list what we're looking for, which is red, compared to what we aren't looking for, which is blue. So 2 to 6. Since this is a ratio, we can simplify it 1 to 3. But we could go a little further and say, what's the probability of choosing a red? Well, you can go back to just the original problem, and we know we have 2 red marbles out of a total of 8 marbles. Another way, if you were just given your odds here, you would take 2 over the total of those. So you could always add those 2 sides of that ratio to get your denominator. Okay, that simplifies to 1/4.